Welcome to the first episode of Tech Talk. My name is Derek Zhang, and today's topic of a discussion surrounds the wonders of aerospace material. Over the last century, aerospace engineering have exploded with novel technologies and crazy engineering capabilities. We've all witnessed the development of SpaceX Starship and the newly launched Webb telescope. Yet these remarkable achievements don't come out of the blue. It took us more than a millennium that can be traced back to Wright brothers' first aircraft in 1903. I've attached one meaningful quote from Orville Wright. We were lucky enough to grow up in an environment where there was always much encouragement to children to pursue intellectual interests, to investigate whatever aroused curiosity. Why is it meaningful? The aerospace industry paved the way of how society operates today, with humans more dependent than ever on products of aerospace industry, such as satellite for telecommunication, transportation via flight, strategic warcraft, and many others. In the next 5 minutes, I will walk you through a few fundamental pieces of aerospace materials that ultimately led to the miracle today. In this session, we will cover what materials are used in aerospace industry, as well as what are the benefits this can bring to day-to-day people like you and me. Let's ask yourself, what is aerospace material and why it is important to our lives? Well, for social benefits, breakthrough material innovation lays the foundation for accomplishing specific milestones, like flying high altitudes and landing far. For everyday people, it is all about the side tweaks along the path of tackling these milestones. You may have heard of NASA's $2 million investment to create an alternative for pencil that doesn't leave flakes or breaking tips. This led to invention of pen that the entire world still relies on, or making something that can hold urine and feces for astronauts in space, which led to invention of space diaper that translate to diaper we use on infants and elders. That was just a warm-up. Let's zoom into the structural level and see what actually contributed to the aerospace application. Polycarbonate, or PC for short, is an amorphous and transparent thermoplastic polymer with organic functional groups linked together by carbonate groups that can be molded freely to suit different needs. It can maintain the texture and strength under harsh circumstances, offer complete UV radiation protection, and great chemical and temperature resistance, making it perfect for aerospace material. Additional properties can be achieved through adding additives like polyester to produce high chemical resistance, or ABS blends for superior processability and toughness. In terms of applications, the favorable properties of polycarbonate plastic make it the perfect replacement for reinforced glass on fighter jets, with only half the weight of glass and much improved impact resistance. Moreover, PC can also be seen in safety goggles, as well as ski helmets and goggles made from this polymer. But wait, if PC can be used for making goggles, then can it? Yep, you got it. Even our lenses can be made from PC to provide anti-scratch properties and UV protections. Last but not least on the agenda, we have carbon fiber reinforced polymer, or CFRP for short. This polymer is made from heating polyacrylonitrile, which transforms it from single linear strand to double length strand ladder polymer. CFRP is 5 times stronger than standard steel and twice as stiff while offering much lighter weight, making it ideal material for manufacturing. Furthermore, it also has favorable properties like high tensile strength, high durability, and high corrosion, chemical, and temperature resistance. In terms of applications, carbon fiber reinforced polymer is the most extensively used aerospace structural material, with a major application being structural components of the wing box, empennage, and fuselage for both commercial and military aircrafts. In addition, Due to the cheap manufacturing cost and the abundance of the raw material, this polymer is widely used in our lives. Any structural material can be fused with carbon fiber to produce extra structural support and protection. Interestingly, the new Winter 2022 Olympic torch was also made with carbon fiber, making it much lighter for runners to carry and more hand-friendly compared to the cold steel torch used in the past. Now, in favor of its lightweight and structural stability, the utilization of carbon fiber can even be stretched to the medical industry. It is found favorable in many medical applications, such as this biocompatible implant. The future is truly limitless. This brings us to the end of today's Tech Talk. Our takeaway for today is that polycarbonate polymer is used mostly for transparent shielding. It is a great alternative for glass. Everyday applications include lenses for glasses, windshield, etc. Next, carbon fiber reinforced polymer is mostly used for exterior and interior structure. It is a great alternative for steel and has plenty of applications. Thank you for listening. Until next time.